So thank you very much for joining everyone. Another edition of the Liftoff webinar series brought to you by the PMT group and sponsored here by Lyft. My name is Joe Steele. I'm the Senior Director of Communications and Legislative Affairs with Lyft. Today we are proud to welcome Andy Sherman from the PMT group, talk a little bit about his advanced engineered materials and magnetics and some of the work that they've got going on. A few housekeeping items before we get started. Everyone should be muted, but if you're not, please go ahead and do so. We are recording this session, so I want to make sure that there's as little background noise as possible. So go ahead and do that. Also, we will have a Q&A session after the presentation, so please utilize the Q&A function using the Zoom toolbar. We are all very familiar with Zoom and other virtual platforms these days. Hopefully we'll return back to normal at some point, but in the meantime, hope everyone is remaining healthy and safe. So you go ahead, utilize that Q&A function. Chat function is a little bit different, so use the Q&A. That'd be fantastic. As I mentioned, we are recording this session, and we'll have it posted up on our Lyft.technology website. You go to the news and events section. It'll be posted there later on this afternoon, so you can catch up. Send it to folks who may be interested in it, folks who thought they could join but were unable to do so, or just revisit anything that any piece of information that you may have missed. So while we are here, I do want to share a little bit of information about Lyft. We are a public-private partnership nonprofit organization here in Detroit, Michigan. We are one of 16 national manufacturing innovation institutes around the country, and we are supported by the Department of Defense. We are a membership-based organization, and our goal is to help advance technologies across the valley of death, from good ideas into commercialization, as well as make sure that the talent pipeline in advanced manufacturing is healthy and robust as well. So with that, our mission is driving American manufacturing into the future through technology and talent development, and we do that through what we call smarter manufacturing. And I'll get into that in just a second, but we believe on the manufacturing sector rests the future of our national economic security and resiliency. And we know that the next region, the next area that tackles that is going to come out ahead. And obviously supported by the Department of Defense being here in Detroit, we want that to be the U.S. So what do we mean by smarter manufacturing? We call that the manufacturing equation, which is the connection between materials, processes, systems, and talent. So we're looking at manufacturing holistically, not siloed just to materials, not just processes, but the connections and interactions therein. So try to look at that holistically, and I think you'll hear a little bit about that in the presentation today and why the PMT group and their companies are involved with Lyft. But we operate really two programs out of our institute. The first is our technology program, Leading Innovations for Tomorrow, and the second is our talent program, Learning Innovations for Tomorrow. Put those together, and you have Lyft. I'll touch on both briefly. Leading Innovations for Tomorrow, our technology program. You'll see there are pillars of technology. These are the areas we focus on. You'll see in those descriptions, really materials, processes, and systems. Looking at on the digital side of things, understanding how to predict how materials are going to react when they're processed is the ICME world. Agile and smarter manufacturing, that's more in the processing world. How can we develop new processes, more agile process? And then advanced alloy process development and multi-material joining. How in the world are we going to join all these materials together once we have them? Being here in Detroit, home of the auto industry, we know that the future of the autos are different materials, and the same holds true. Aerospace, ships, everything, defense, everything. We're dealing with different materials. I won't quiz you on this slide, but this is a little bit deeper dive into some of those pillars of technologies to see all the breadth and depth of where we operate. So if you have questions, please reach out and contact us directly. We'd be happy to walk you through this, and hopefully, if you're in and around Detroit, come visit us. On the talent side of the house, again, about innovation here as well, but it's really new learning tools, pathways, and venues, starting with our foundational curriculum, which is a high school program, a 3-year high school program called Ignite Mastering Manufacturing. That is where high school students are really exposed to the world of advanced manufacturing. What does it look like in the year 2021, from material science to smarter manufacturing? They really get exposed to all of that, and then can guide their decisions, inform their decisions on education going forward. We do host a number of schools participating in Ignite at our Lyft Learning Lab. That is a unique facility because it is housed in our 100,000 square foot Detroit facility. So students can come in and look out the windows and see all of our technicians and members hard at work working on the technology advancements for tomorrow. So it's really, by osmosis, they're learning in a number of ways. We also provide certification programs for jobs that are available today. CNC operations, robotics, welding, industrial technology, maintenance. You can see we connect with a number of national accreditation bodies to make sure that folks are getting nationally portable, industry recognized credentials. And then Operation Next is one of the programs we're most proud of. That was born as a program for active members of the military before they get ready to separate from the service, give them the opportunity to earn a credential in some of the most in-demand jobs so they can begin their civilian career immediately upon leaving the gates of their service. So that program remains active at Fort Campbell in Kentucky. It was recently expanded to the Hampton Roads region of Virginia. It is available to the Michigan National Guard, the Wisconsin National Guard, the Florida National Guard, and we're looking forward to more expansions here in the near future. So stay tuned for that. One of the programs we are most proud of. So I mentioned that we are a membership organization. So what do you receive as a member of Lyft? Well, everything you see on the screen here. Again, we're a trusted advisor when it comes to technology and talent advancement. We are not selling a specific product or service. We're here to give you the best advice we can from our in-house expertise, as well as the expertise from our ecosystem. We've got 300 plus members around the country to be able to pull from. I mentioned we're a technology accelerator, trying to move these technologies across the valley of death from good idea to commercialization. We can't commercialize things. We're not in competition with our members. We want to help enable them to move these technologies forward. Technology Showcase, I mentioned our 100,000 square foot facility in Detroit. Come visit us. We're happy to show you around, show you the future that we have here in advanced manufacturing. We're a connector and a convener. Thanks so much for joining us today. That's why we're all here, to hear from some of the brightest minds in advanced manufacturing, pulling from our ecosystem all around the country to let you know what is going on, what the future holds. A talent developer, I touched on that already, from high school students to veterans to incumbent workers. Across the education continuum, we're trying to make sure that the talent pipeline is robust and healthy for advanced manufacturing going forward. And finally, we are a government partner. The federal government can be challenging, overwhelming to work with. We are a conduit to help do so, particularly on the small to medium-sized company side. Helping enable them to work with the feds is one of the things that we can do. So thank you so much for listening to Lyft in a nutshell. I know you didn't come to hear from me, you came to hear from Andy, but please reach out to us if you have any additional questions. You can follow us on our social media avenues, as well as pick up the phone like olden times, or send us an email or visit us on the website. So thank you so much for that. And with that, I'm going to turn it over to Andy from PMT Group to talk about the advanced engineered materials and magnetics. So Andy, I'm going to stop sharing my screen and hand it over to you, sir.
Okay. Can you see my screen?
It started. Oh, yep, there we are. Gotcha.
Okay. Thank you, Joe. It's a pleasure to be here. We've been involved with Lyft since the start, really through our lightweighting and hypersonic materials efforts. So we're not too far from Detroit. We're over in the Cleveland area in Euclid. So I'm going to talk today, give you an introduction to Powdermet, PMT Group, and the 7 organizations that are part. Let's see how I advance. So Powdermet is a family-owned group, middle market companies. There are actually 7 companies as part of the group, and historically, we started 26 years ago as a spin out of the powder metallurgy group, refractory metals and hard metals, spin out of a company called Ultramet in California. They're a major supplier of refractory metals, chemical vapor deposition, and ceramic composites, and also into biomedical applications. So PowderMet was the first company there. Of the 7 companies, they're organized separately, but all report and we share resources and a facility. And they are involved in corrosion protection, lightweighting materials, magnetic materials, thermal energy storage, high temperature, extreme environment materials, and advanced coatings. So I mentioned we've celebrated 25 years last year from our founding in 1996. That was really based on the concept of, was really based on the iron carbonyl particle and building in a nano-engineered structure into a repeating particle building block. We called it Nano Encapsulated Powder Metallurgy. And we basically built in nano features into powders, controlling their electrical, mechanical, CT, physical, thermal properties. And we continue to build on that. Build on that platform, including dispersion into polymeric and advanced polysiloxanes, metallic materials. We are a producer in 2016. We added a magnesium foundry and extrusion facility. So we are one of the only vertically integrated magnesium extrusion supplier in the United States and indeed North America. We've had 5 R&D 100 awards recognized over the years, a lot of collaborations with national labs, with universities. We've licensed in a significant amount of technology, and our role is really commercializing, industrializing advanced materials technologies. I'm going to get into selected products and capabilities, including really focused on the lightweighting applications. Some of these include extreme environment materials that extend the life and allow operation in molten salts and other extreme environments. Our magnesium products, our energy storage products, and our coating technologies. So some of these, we do provide standard and high strength magnesium alloys extrusions, as well as castings, composites, and fiber metal laminates. We also, historically, we've been a particle feedstock provider, providing thermal spray feedstocks, nanoparticle synthesis, agglomeration, surface modification, dispersion, granulation, and temperature program reduction and oxidation services. Originally worked focused on fluidized bed processing, gas solid processing, but later into hydrometallurgy and various spray drying and other processes that we've added over the years. I'm going to talk a little bit more about our thermally engineered our metal matrix composite materials, including Insuloy, which is a very lightweight, thermally insulating syntactic composite. Our micro composite, our nano composite, nanostructured metallics, which we offer in aluminum, magnesium, and titanium. We've done some work in the ferrous systems. S-Comp is a high energy absorption, tailored. It's the highest energy absorption, can absorb dissipating through plastic deformation over 300 joules per centimeter squared. Hybritherm is a series of CTE and thermal conductivity engineered lean composite metal alloys, titanium, niobium, iron, nickel, and cobalt alloys. And these are for thermal management and hypersonics, managing thermal mechanical stresses in extreme environments. And Hybromet and Hybricomp are nanocomposite ceramic materials for wear and corrosion protection. We're also introducing and providing rapid prototyping, largely using additive manufacturing casting techniques, as well as spark plasma sintering for rapid production of refractory ceramic and composite materials. I'm going to spend most of my time talking about magnesium, which is one of the reasons we joined Lyft. We are the only vertically integrated magnesium producer in the United States and in North America. Magnesium is the lightest structural metal. It's 33% lighter than aluminum, and it's 70 to 80% lighter than steel. We have introduced new alloys that are equivalent to 6,000 series aluminum, above 50 to 60 KSI and went up to 65 KSI, absolute strength. So they offer 30 to 35% weight savings over aluminum materials. They also offer high damping, have high strain to failure. We're focused on transportation, drone, and space vehicle lightweighting, and have several very high temperature alloys as part of these applications. We also produce and have developed some thermally engineered magnesium materials incorporating carbon nanotubes and carbon fibers that have controlled CTEs and enhanced thermal and electrical conductivity. Our facilities include a 3,500 metric ton extrusion press that can handle, basically takes 9-inch billets and produces materials on that. Permanent mold casting, billet mold casting, pressure assisted casting, and squeeze casting. We do have full machine shops. We do produce, our largest business is actually dissolvable oil tools made out of magnesium. They're lightweight and they're designed, spent my whole career combating corrosion in extreme environments. And our largest product today, commercial success, is making metal alloys that dissolve and go away quickly under controlled conditions. So they hold 10,000 PSI and then disappear. We do have a new vertical direct chill cast billet and slab caster that's being installed this year. That is under contract, and we expect to expand from extrusions into plate and sheet production into 2023 to 2024. As a partnership with Lyft, we have installed and are operating a 1,000-ton Hydra forming press, which is a pretty significant asset. And the initial projects are really working at, there's 2 projects. One is a formable fiber metal laminate for bucket seats, very lightweight bucket seats, and the other is frame materials and bumper rails for automotive lightweighting. Another addition is we are currently scaling up to the 10 kilogram scale as the first U.S. producer of metallic rare earths and master alloys, using metallothermal reduction in our existing infrastructure. What we've been developing, we originally entered the magnesium. We did a lot of work in magnesium composites for electronic boxes and lightweighting and space application and electronics, going back 23 years or so, as well as magnesium hydrogen storage. But since then, we got into the dissolvable materials, and we've been developing proprietary and high strength alloys useful for lightweighting. And these include very high temperature, high strength, long period stacking order nanocomposite alloys that are, 6,000 and 7,000 series equivalent, up to 500 megapascal materials, and some low cost 6,000 series heat treatable materials that are very low alloys. We also have some high formability ductility alloys, room temperature formable extrusions, and eventually sheet, and in a lean high temperature alloy that is for high temperature casting applications, that has no neodymium and is more friendly on the rare earths and lower cost than traditional EV31 and WE43 materials. We also produce and have developed composite materials, including laminates and CTE tailored materials. These offer really the same performance as carbon fiber composites, but save over 50% of the cost in manufacturing. And we're developing with the Hydra press advanced forming capabilities for these laminates and co-processed tubulars and shapes. Applications include battery containers, A and B frames, bucket seats is one of the applications, optical benches, very high damping, very high strength, very low weight materials. One of our newer alloys that we've been working with Department of Energy and Lyft and Ohio State University is a ZACM. It's a low alloy zinc, aluminum, calcium, manganese material that is formable at room temperature. It's designed also to be formable. We've modified these this and other alloys to get much higher process speeds during extrusion and eventually in slab rolling. And this is a material that basically in terms of strain to failure, elongation to failure, and strength really forms a new paradigm. It is substantially stronger, lower cost, and more ductile than any existing magnesium alloys. So it has after heat treatment, it's very processable as homogenized, but after heat treatment, this is a 280 megapascal yield, 340, 350 megapascal ultimate with over 20%, up to 30% engineering strain to failure. And this is specifically engineered for formability and for crash energy management and energy management in automotive and transportation structures. Another alloy that we are now offering is a 6000 series direct equivalent, 65 KSI, aluminum, calcium, manganese alloy that is low in cost, has really tremendous properties, 65 KSI, 450 KSI, megapascal strength. And again, we've been modifying existing alloys for processability. Two additional alloys that I'll introduce is VEK 410, which is a neodymium-free WE43 and EV31 alternative designed for low-cost, high-temperature castings. So this is good for temperatures above 200 centigrade to 300 centigrade. It is a very high-strength, high-temperature alloy. And then it is a 22 KSI yield strength, 38 KSI ultimate strength, and that's as a sand casting. And then we have a forging and extrusion alloy, VWZ 942, which is a long period stacking order. This is stable to above 280 C centigrade, and in the age condition is directly comparable to a 6061, which much better thermal stability. So it's 57 KSI yield, 58 KSI ultimate as T5 aged. And this can take again, stable to elevated temperatures. And so it's, applications in military equipment, missile tubes, bulkheads, anything that's seeing high temperatures and very high stresses. So gun parts is one of the applications for this. As I stated, a new capability that we've installed now, and it is ready for processing, is a 1,000-ton interlocking Hydra press that allows forming of extruded tubes and shapes. These are bumper beams, A-frames, and other automotive components that are able to be bent and formed into complex shapes with internal pressure, and also for forming of laminate structures with co-curing of either a thermoplastic or a thermal setting laminate. So these are the applications for it. This is really to verify manufacturing costs, formability, develop tooling and processing conditions for processing not only these advanced alloys, but the composite materials and the laminate materials as well. This is a system that is available for lightweighting demonstration projects. And one of the things as a family-owned company, there's about 50 employees at the company, is we are constantly looking for partnerships. And one of the reasons we're with Lyft is for the collaboration and the co-development and collaboration opportunities working with the manufacturing center. Another capability that we've offered and are offering is hydride, dehydride, and refractory alloy powder production. So we have 1, 5, and 100 kilogram batch systems, and we're processing titanium alloys, niobium alloys, high entropy alloys, and magnetic materials. Includes scrap washing, deoxidation, and we also have vacuum suspension melting for custom alloys and arc melting to do both magnetic and refractory materials. We do have a pilot plant melt spinner that is coming this year as well to allow us to do rapidly solidified. So we do particle size reduction, vacuum milling, vacuum processing, all very low oxygen content, and have extensive handling of oxygen sensitive and atmospheric sensitive materials. We also have being installed 10 and 200 ton spark plasma sintering equipment that allows us to rapidly prototype equipment, and we're working with Lyft and Ohio State and others to actually develop net shape processing, rapid prototyping using these field enhanced sintering techniques. Extensive agglomeration and composite powder fabrication. We do produce feedstocks through spray drying, granulation, mechanical alloying, and others. Hybritherm is a patented, it's a proprietary thermally engineered, including coefficient of thermal expansion and thermal conductivity, lean metal matrix composite. We are producing these in niobium, titanium, nickel, and ODS oxide dispersion strengthened materials, iron-based materials. And these are reinforced with high thermal conductivity and low CTE materials. They have basically the ability to add 50 to 400% increase in thermal conductivity, tailor the modulus and reduce the CTE, and reduce the density and the cost. Take away putting lower cost material fillers in for the higher cost refractory metals or nickel alloy materials. And these do have enhanced mechanical properties at elevated temperatures. A lot of the focus on these is limited duration applications right now that have lower qualification. And we're actively seeking partnerships to insert these materials in limited life applications and to enhance production and get into value streams, while the longer term fatigue and long duration properties are proven out in applications. They do offer advantages in hot structures, being able to tailor and move thermal energy around and tailor the CTEs and the residual thermal stresses and the thermal stresses due to extreme temperature gradients. This leads to elimination or reduction of hot spots, buckling, thermal distortion, and in attachments and putting dissimilar materials together basically help bridge the differing expansions, temperatures, and thermal stresses. And these can reduce significantly the density and mass. And these are really a whole platform of engineered materials that we can now tailor thermal and mechanical properties to basically optimize a design. And it opens up an entire degree of freedom. And when you combine this with some rapid prototyping and additive manufacturing, it really opens up design space to particularly extreme environment and high thermal gradient structures that are used in materials processing, hypersonics, high-speed systems, engine systems, by engineering the structure with another degree of freedom, which is the thermal properties. On the other end of this is if we fill these up with aerogels, ceramic aerospheres, or microballoons, we can make thermally insulating metals that also have tremendous energy absorption capabilities. So these, one of the early demonstrations is the backing. These are strong enough to actually support a ceramic, but can absorb 1/3 to 1/2 the energy of a fragmenting projectile or a kinetic weapon strike, basically eliminating, greatly reducing or eliminating backface deformation and intrusion. So applications of these, magnesium and aluminum versions and steel versions include dangerous good transportation. We are looking and actively exploiting dangerous goods transport. A lot of our oil today gets transported by rail or by truck. So managing crash and energy impact, these are tremendous for those applications, as well as managing fire events, thermal events, and impact events. So as an energy management, lightweighting, energy absorption, we can pretty much tailor these again, tailor the structures such as a plateau crust strength, and tailor them to an application, whether it be a projectile impact or a mechanical impact due to a collision or an explosive event. Generally, these are between 5 and with titanium versions up to 30 to 40,000 KSI or PSI crush strengths. When these are impacted and deformed, they actually, the microballoons or the fillers crush. If you can see on the right, I don't have a pointer here, but there is basically here's a parent structure. It looks just like a normal metal. And after compression, it basically turns into a metal matrix composite. And depending on the formulation, here's an aluminum 2 gram per cc material, absorbing 275 joules per cc, which is an extremely high energy density. That's 500 tons of absorption, impact absorption in a 6-inch diameter cylinder, which was one of the looking at couplers for trains and for transportation application. And this allows an engineer to actually tailor the force transmission to basically clip it and extend that impact over time. So a lot of very interesting applications. Here's electronic boxes for Emi shielding. These are extremely lightweight. The magnesium versions of these are right about 1 gram per cc, 1 to 1 gram per cc, formable, moldable, machinable, and very nice lightweighting structures. Continuing on this theme, Boromet is if I take those cores out and replace those with a nano composite, a nano structured Ceramatech. Tungsten carbide is the baseline, but we also offer titanium nitride and borides. We get a structure that, and we put those into a matrix. We get a structure that is both extremely hard and wear resistant, up to 2,600 Vickers, but also extremely ductile. So same properties as tool steel, 26 K1C, and significantly strained to failure. And this has particularly usefulness in high load bearing applications and wear applications, bearing sleeves. We offer this in both a consolidated version and as a coating for structures. And by tailoring that matrix, we have versions that are compatible with molten salts at up to 800 centigrade with supercritical CO2. And with very poorly lubricating environments, such as basically using water as a lubricant to get reduced friction and frictional forces and losses due to friction. Basically, because of the nanostructures, these form a hydrodynamic film, even with a 1 centipoise salt water, so that they are basically lubricating and very low wear and very low friction with any kind of simple lubricant around. They also tend to be one of our, going back years and years, they can be self-lapping because you can tailor the hardness of mating surfaces. One of the original applications that this was based on was space shuttle hydrogen shutoff valves, where the poppet and the seat had different hardnesses. And if there was a particle or something in there, they would self-lap and reseal after use. So these are very useful in valve, particularly high temperature valves and extreme environment valve and flapper and wear applications. We do offer these in both a spark plasma sintered version, up to 8-inch diameter parts, as well as in thermal spray packages. So here's just some applications of the coatings. In sand wear abrasion, these are considerably better than hard chrome or conventional thermal spray materials, while they can take extreme stress. In the upper right here, one of the application is in roller crushers used for sizing iron ore. These replaced a stellite weld overlay and increase the life from 2 to 3 weeks up to 6 months with just a coating. On the left there, one of the other applications is plungers used in fracking pumps that are pumping sand at very high velocity and high pressures. as well as progressive cavity pumps used in steerable oil drills and downhole tools. We also offer Boromet, which is an advanced boride material that is exceptional in molten metal corrosion resistance. What you can see in the lower right is a zinc pot roll that's used for producing galvalume coated structural high quality automotive steel is the big application for that. It is also a unique material because it is roughly 850 hardness. So it has the same mechanical and wear properties as chrome, but has actually no hazardous materials in it. So it is totally compliant with REACH, and it is a potential excellent alternative for chrome replacement in a very environmentally friendly application. Moving on, one of our newer starts, we've done considerable work over the last 25 years in ceramic extreme environment materials, pre-ceramic polymers. We've collected actually a lot of the experts in polysilazane chemistry and are launching Ceramatech. This is some work that came out of the oil and gas industry, providing corrosion and wear protection at elevated temperatures. It keeps going up. It started at 400 Fahrenheit and it's now up to 600 Fahrenheit in some applications. So this is a tailorable material based on polysilazane compounding. It can provide extreme wear resistance for abrasion resistance, extremely resistant to a lot of corrosive environments, particularly oxidizing systems. So sulfur, sulfuric acid, nitric acid, these applications to high temperatures. And there are versions of this that are stable up to 600 centigrade and above, depending on these. So this is we are developing this as an alternative to weld overlay cladding for oil and gas applications, as well as boiler tubes. It also forms a molecular bond and is extremely corrosion resistant and bonds very well to aluminum and magnesium as an alternative to or an enhancement to anodizing to color and corrosion protect light metals, which is another of our applications. Moving from there, we also are developing and using it as a binder for putting together high temperature magnetic materials. And these are for rotors and stators in electric motors. And the polysilazanes, because of their stability to 600 C, allow you to do field annealing and crystallization of metal amorphous nanocomposites and magnetic materials at up to 600 centigrade after fabrication. They're also excellent insulators, very high dielectric strength. Magnet Energy is a new start. We have licensed manganese bismuth technology out of the Critical Materials Institute. Manganese bismuth has no rare earths, and it has the unique structure of having a higher coercivity with temperature, a positive coefficient of coercivity, which means it's extremely resistant to demagnetization at higher temperatures. And it actually has an energy product that is better, can approach or be even better than rare earth magnets at elevated temperatures. This is important to lightweighting, both for cost, but as you run a motor at higher speeds and higher temperatures and get rid of cooling, you can make them much more power dense. So this is something that we're working on today. We are a member of AMPT, which is the Advanced Magnetic Partnership with Pittsburgh and Carnegie Mellon and North Carolina State. And we're working on both this. The melt spinner is helping us out with this for rapidly solidifying these materials to move them into production. So we're moving this from gram scale and to tonnage scale over the next year and a half. So these materials, actually manganese bismuth has, in terms of energy storage per unit dollar, these are actually about 3 times as effective as ferrets in terms of joules per dollar, and they're about 5 times as effective as rare earth magnets. And again, they are stable to high temperatures and offer a nice material for motors and high temperature magnetic applications where coercivity and demagnetization resistant is important. Another material we're working on with Case Western Reserve University and is double alpha prime iron nitride, which has the highest magnetic saturation of any material. So applications in magnetic calorics, and we're working on enhancing the permeability or the coercivity of that material because its theoretical energy product is actually higher than rare earth magnets. Another area in the magnetics is metal amorphous nanocomposite, single crystal, and nanocomposite flakes. These materials actually have extremely low losses and are used in high-speed motors, in the rotors, in the soft magnetic materials, as well as in wide bandgap semiconductor devices, allowing operation at 200 kilohertz and above, with magnetic saturation well above 1 Tesla. So this is still being developed. It's not perfected, but it is an emerging right now in power dense power converters, uncooled power converters, and high power density. The magnetics are actually limiting materials. Magnetics and insulation are actually limiting the application and adoption of some of these technologies. Finally, related to the magnetics, we are working with, collaborating with the Critical Materials Institute. I think you can hear a theme here. And we are putting in, and actually we are at the 1 kilo scale, the 1 liter scale, and scaling to the 30 liter, which is about a 10 kilogram batch size right now, actually over the next few months. For metallothermal reduction, calciothermal reduction of metal oxides domestically produced and reclaimed from waste streams, including waste hard disk drives. And we have now produced and purified neodymium as well as gadolinium systems that we're actively working on. And we're working towards, hopefully, with if everything works out, that we will be at the multi-tonnage scale sometime in the 2023 and 2024 time scale. So that's basically some background. There's a lot else going on in history, but we're really here to reach out for partners, stakeholders, collaborations. We are particularly good at making high purity and low oxygen, phase pure, difficult to fabricate powders and agglomerates and high surface area materials, controlling oxygen, carbon, nitrogen, other contents for lightweighting, electric vehicle, aerospace and defense application, as well as oil and gas, which is one of our larger businesses. So we are actively looking for partnerships, collaborations, and really are pleased to be a sponsor member of Lyft and to be involved in this partnership. So I'll just leave this one up. We've got a lot of capabilities that we can bring to bear in collaborations with advanced materials: chemical vapor deposition, fluidized bed, hydroclave synthesis, nanoparticle synthesis, SPS, a lot of furnaces. So a lot of processing of extreme environment and difficult to handle materials, including, we're producing over 500 tons per year, roughly about 500 tons per year of magnesium, wrought magnesium materials, and they're advanced alloys. So we look forward to working with people and with Lyft to move these further into the lightweighting value chains.
Awesome. Thank you very much. And I'm glad you had the contact information there, so folks on the call can reach out to you with specific questions, partnerships, ideas, etc. I mean, that's what we are here for as well. As I mentioned, we are trying to bring folks together throughout our ecosystem. So please reach out to Andy or his team with any questions. Also, we do have some time for a Q&A session. So if you have some questions, please fire them up on the Q&A function that we have here on the Zoom. Andy, I mean, I told the assemble folks here that we would know why you guys were a member of Lyft and why it made sense before your presentation, and certainly did, touching on every material under the sun, including some of the work that we, we're obviously involved in the hypersonics world as well, and you touched that. So I think that I know we have some of our technology team on the call here as well. So I've no doubt their minds are moving in terms of how we can work together additionally going forward. But I really did want to touch on, you talked about the equipment that we were able to work together on to move down to your place. Can you talk a little bit about that that piece of machinery? I know you touched on it, but what kinds of projects you're looking for in terms of that hydroforming press?
Well, it's a very unique capability. It's a highly instrumented press, and we were real pleased. You know how that came about. We put in to use it at your place, and you said, "Well, you've got a lot more use for it." So,
yeah. I mean, it made sense, right? So if you guys, and that's just how we can work with our ecosystem. That we have had other pieces of machinery moved to other places. If they can utilize it, sure, we'll work with you and have that happen. So.
But yeah, really we're focused on with our DOE partnership. Magnesium is, in terms of carbon life cycle CO2 savings, magnesium is probably the best material for lightweighting in terms of life cycle CO2 cost. It's low energy content, it's easy to recycle, it's got low energy in melting and processing, and it's very lightweight. Particularly when we start combining it with multi-material structures. And the hydroformer is really to go the next stage. I mean, we produce extrusions. We're looking at adding plate and sheet. But to make it into structures, there has to be economic high rate forming. Mm-hmm. And the Hydro press is there to take our extrusions and go through the bending and forming process into beams, into structural shapes. As well as to take laminates and multi-material forms and co-process them, co-cure them. Both working at cold up to about 250 centigrade, hot oil systems. And that's a unique system because it can apply both internal pressure in an enclosure as well as up to 1,000 tons forging press, and it has about a 5 by 4 foot active area. Mm-hmm. I had the dimensions there. I think it's 68 by 49 or something.
I don't remember off the top of my head. Exactly.
So it's really a unique capability, and we're really just have it installed, and we're getting started with it. Really for forming tubulars, complex shapes, putting crimps and stiffeners in, going from extrusions to end product, and going from really laminate sheet to an actual product. So things like cross members, cross beams, bumper frames, A-frames, structural frames. We're looking at applications in commercial lighting. When you're hanging things from ceilings, anywhere you need lightweight with the laminates, high stiffness or high strength materials and applications. So that's what it's all about.
Yeah, well, like I said, we're excited that to work with you on that, and glad you're able to have it down there and put it to some use. So, questions from the assembled crowd here. Has your company taken a look at scandium enhanced aluminum alloys at all?
We haven't really worked in the cast aluminum field. I mean, we have worked with actually Lyft, providing nanoparticle feedstocks up to Tech Industries, and working on nanoparticles enhancement, using some of our extensive experience in basically surface modification and dispersion and synthesis of nanoparticles to help make additives, but not specifically into the scandium. I mean, we are following the cerium and the scandium, and there is we've been looking at what can we do with magnesium, because really our focus is almost entirely on magnesium in terms of the foundry and the molten metal processing.
You brought up magnesium, and actually a question from our team. Have you seen any growth in the interest in using magnesium MMC materials in wheel end products like brake rotors? We have some work going on there. So question from our team on that.
We are actively looking at collaboration. We've done some basic development in that area and are able to start supporting that area. It's, the oil and gas sector has been through cycles. So we looked at diversification into lightweighting in these applications. But certainly between the syntactics and energy absorption, extreme lightweighting cores, and combined wear and thermal management and the high temperature alloys, pistons, brake rotors, and that's part of it's all about how do you fabricate it cheap enough so that the end product is attractive to the end users. We are really looking at some of the performance aftermarkets as insertion places.
Right. Have you seen more interest in that in those materials though for those uses, or you're just getting started?
We're just getting started. We're starting to seed it. I mean, there really hasn't been a magnesium capability in the U.S. Mm-hmm. There really hasn't been production, and everything's it's like the magnet world is we're bringing it back, and as a family business we can do that. Invest heavily in domestic manufacturing. I mean, we really lost all magnesium, all magnetics. Have all gone to China and Asia, not just China, but Asia in general. And so we're basically just getting back and starting to industrialize. And with that, it's really, it's been in cycles. I mean, there was a whole lot of interest about 10 years ago in the magnesium and magnesium composites in the automotive. It's still part of really the overall lightweighting plans, and part of it's administrations and other things. When the CAFE standard went down, lightweighting it became more of a performance environment. Now it's all back. So we are starting to see increased interest.
Mm-hmm. Got it. A couple questions. We may run out of time with the questions that are coming in, but I will make sure to send all your questions to Andy afterwards so we can follow up directly. What sort of turnaround time exists for the production of custom batches of powder, 100, 200 kilograms?
Really depends on the materials. If it's if it's something that we're already producing, well, I mean, today is just the whole material supply chain.
Right. I think that's what prompted the question,
I
right?
Containers of materials stuck in a port for 8 weeks. So it's really it depends on if I have stuff in stock. So it's varying. From today about 6 weeks up to 12 to 14 weeks. Okay. So supply chains today, it is our vision to be able to make rapid prototyping and to basically cut these cycles through the processing and that we can do. Yeah. It's a big challenge, and it's something we're actively working on to be able to cut those lead times and basically stock materials and being able to provide short lead times, because lead times today can be up to 20 to 24 months for some things. My goodness. So we're really trying to shorten those lead times down with the collaborations and the partnerships and technology.
Yep. Well, speaking of having those kinds of things available, what kind of niobium alloy powders do you have available, if any?
We have been validating, reprocessing, basically niobium mill scale or scrap, the machine turnings into powder metallurgy feedstocks. So that's primarily C103. The alloy we have really been focusing on is CB752, which is basically a high temperature. It's a medium strength, but it's got about 10% tungsten and 2% other strengtheners in it. It's a pretty good material, very amenable to the PM processing, and it's got some pretty good high temperature mechanical properties. And we've been doing a lot of work with adding reinforcements to enhance high temperature strength and properties. particularly creep and compressive strength at temperature.
I'm going to combine a couple of questions here about corrosion, asking for multi-material applications, what advancements have been made for corrosion resistance, and if there are any environmentally friendly corrosion protections for magnesium specifically.
Well, that's, there are a number of answers. That's as we move into these long life applications in automotive and transportation, it's there. So we are actually actively working on microalloying dopants that are cathodic poisons that can enhance, basically make stainless magnesium and make it inherently more corrosion resistant. There is magnesium that's been out there in environmental applications, for 100 years. That still looks fine, but corrosion is a concern. The other area that we've been really working on ourselves is the polysiloxanes, the polycarbosiloxane-based coatings, and they are very environmentally friendly. They're basically analogs to silicone, but with amine functionality, and they form very strong bonds. There has been a lot of work in the enhancements in the pulse basically the pulse anodizing technologies, and there's a number of new providers. So between the polysiloxane coatings, the things like Cerakote and the PEO type materials, these are getting to be fairly prevalent in the sporting goods applications, which has tended to be, shorter qualification times. They haven't really been adopted yet into the transportation and a longer life. But again, that's kind of a natural sequence.
Right. Unfortunately, we are running out of time, and I want to be conscious of people's time here. So I do want, if we did not get to your question, I would encourage you to reach out to Andy directly. You can reach out to us here at Lyft, and we'd be happy to put you in contact with Andy. So I want to thank everyone for joining today. I want to thank Andy for his presentation and his membership and his partnership with Lyft. So thank you very much. Thank you very much, everyone, for joining today. Again, reach out to Lyft if you have any further questions, or reach out to Andy directly. Either way, we can make that connection. Stay tuned for your emails. We have another webinar next week. Speaking of hypersonics projects and materials, our member ATC will be speaking on moldable RF materials for hypersonic sensors and seekers. So stay tuned for that. Coming to you next week. So in the meantime, I hope everyone has a great day. Andy, again, thank you so much for the presentation. We appreciate you. Appreciate all the work that you guys are putting in, and looking forward to working even more closely with you.
Okay, thank you, Joe.
Thank you, everyone.
It's my pleasure.